India happens to have the opposite of space. So we think that it's the right time to build a tailor-made solution for India that is an electric air taxi. Sarla Aviation is building flying cars, air taxis, eVTOL, whatever you want to call them, advanced aircraft that essentially bring personal mobility, point-to-point mobility to the country. So we're building aircraft. We think that if you look at the history of mobility solutions across, or sort of since the industrial times, I guess, you can see that like different mobility modes have taken off in different places in different ways. And really what we have seen is that ground transportation such as trains and cars work particularly well in areas where you have a lot of land available, so you have space. Now India happens to have the opposite of space. We have the most densest populated nation here, and that leads to an inevitable problem of scarcity for space on the ground. And so that's basically why we see 4 out of the world's 10 most congested cities are being here right now. Cars are being stuck in traffic everywhere, even though only 8% of Indians even own a car. So ground transportation fails to scale in India. And with this new technology that's available of electric aircraft, so with an electric powertrain powered aircrafts and propulsion mechanisms, what is possible is that we can build the right mobility system that India was sort of looking for all these years, because all the other ground-bound modes of transportation have failed here. So we are solving for traffic, we're solving for mobility, we're solving for a bottleneck in our GDP growth, all of these things we want to solve. So I think the right time is sort of given by technology advancements. And also comes with the right team. So my co-founder Rakesh and Shivam, both of these guys and I, we all used to work in the West, in Germany and in California, where we were building flying cars for Western countries, such as Shivam was at Joby Aviation, Rakesh and I were at Lilium, and really what we believed is that the technology for electric propulsion and for flying cars, for point-to-point connectivity in the air or through air, is now there to scale. Now it's a manufacturing and an engineering problem, and not so much a research and development problem anymore, a science problem anymore. So I think that technology unlock that has happened over the last 10 years in the aviation industry is a major part why we think that it's the right time. And also, I think that sort of combined with India and the stage of, or the state of the Indian economy currently, we see that India is the most desperate for a functioning mobility system out of all the different countries that you have available. And so we think that it's the right time to build a tailor-made solution for India that is an electric air taxi. So that's why we came here. So when you're building anything with an electric powertrain today, whether it's a car or an aircraft, or anything else with an electric powertrain that is basically linked to a battery that then powers your aircraft, you have the choice between payload and range. That's true for cars, that's true for aircraft. So if you have a higher weight, then your range will be lesser. If you have a lower weight, then your range will be further. And for us, the very foundational assumption that we are taking here is that because India is a very densely populated country, the distances that people travel here, whether it's commute to work or anything else really, they vary between, let's say, like 2 to 30 kilometers, somewhere in that range. And if you live in Los Angeles, for example, in the States, your commute distances are significantly longer. They're double, 3 times that kind of amount. So what we have been trading off in our design essentially is that our assumption is that if we can increase the payload of the aircraft at the cost of range, then we can make it a lot more affordable, because if you can transport 6 passengers versus, in the West, like these competitors are transporting 2 to 4 passengers, then your operational cost will be split by a higher number of passengers. So it's a pretty straightforward math, really, that we're applying here. And that is leading us, Sarla, into being a truly mass transportation capable flying taxi, and not just something for the elite. Yeah, absolutely. So there are different ways that you can build a flying car today. There is the tilt mechanism. That is basically you take off vertically like a helicopter, or a drone, a quadcopter, and then all of your propellers, as you transition into forward flight, would change their approach angle, so they go from vertical thrust production into a horizontal thrust production. Now that requires a difficult to build mechanism. It's a highly complex mechanism, which again leads you to longer range. It's a little bit more efficient, right? But in our case, we wanted to keep everything simple, because simplicity means that it's more affordable, means that it's lesser maintenance, all of these things. So simplicity really comes with all of the upsides, we believe. So in our case, we have chosen an architecture that's called hybrid lift and cruise. So we have a set of propellers that lifts us up vertically in the air, and then a set of propellers that pushes us forward as we start gliding on our wings. And we only have 2 tilt propellers which are on the wing tips, and they only change their approach angle. So by that technology, we are able to reduce the complexity, again, at the cost of some of the efficiency of the range that we can achieve. Well, that's a huge question. I think that really what we're seeing right now in India is, or let me put it that way. I think the challenge that we have here in India is pretty unique, but it's also the opportunity that we see here. We don't have a Boeing of India right now. We don't have Lockheed Martin. We don't have GA. We don't have Airbus. All of these great aviation companies, they're not typically based in India when it comes to manufacturing and supply chain. So in our case, the problem really doesn't lie in like one component specifically. The problem is sort of in developing a whole ecosystem that we can then leverage to build these aircraft as an OEM. Really, today you only have HAL as the only true aviation OEM in India, and HAL is a public company. Sorry, a government company essentially. So the kind of efficiency of timeline and use of capital is not as good as it could be. So what we believe is that our biggest challenge is to establish a privately held manufacturing ecosystem for aerospace parts, and that's where the real breakthrough for India as a manufacturing hub will come. Yeah, I mean, again, kind of goes to the point that I was just saying. I think that there are highly capable companies that we are lucky to work with. Whether it's from motor development or composites development, like all of these things are there. But the capacity that we see them or in the scale that we see them operating at right now is not large enough, and not sort of aviation grade enough. Like the quality standards of it have to get better over time for us to really be able to build hundreds of these aircraft. And that's the goal here, right? This ideally would be a production line that you only know from cars today, and not so much from aircraft. So we are choosing our suppliers very thoughtfully right now, and we're incentivizing our suppliers as well to develop certain components that they maybe haven't thought about yet. The beauty of electric aviation is that the powertrain is a lot more simple than it used to be with ICE engines, with turbine engines, and so forth. And so what we are leveraging is not just the component suppliers for aircrafts, but also a rapidly growing electric manufacturing capacity of India, whether it's from two-wheelers or four-wheelers. I think the EV space is something that we're looking at somewhat as a role model. I think that in aviation, the typical mode that you would have in an app-based or sort of software-based company doesn't really exist here, because this is difficult to develop technology, difficult to develop supply chain, difficult to develop infrastructure. So the mode here really is that we have the best team, and the best team will deliver on the best quality products, and the best quality products have to be built with the best quality supply chain. And these things, over time, they're so difficult to develop, they take so much time to develop, that at the end, it's a really difficult market to sort of break into. And I think what we're seeing right now is that just everyone is sort of like trying to find their space and make it happen. But it's difficult to pin it down to one specific component that we do better than the other ones, because every aircraft component is specifically developed for that aircraft. You cannot just take one motor from one aircraft and put it into another aircraft. This takes time. Having said that, for us, at the core of the technology that we're developing, I would say the powertrain is the one thing that we really have strength on, this vertical takeoff capability for aircraft systems, that then can transition into a forward wing-borne flight. That powertrain is at the heart of the technology that we develop. Yeah, vertiport infrastructure is actually a great sort of question in and of itself, because what is vertiport infrastructure? Really, a vertiport is just a flat piece of land, 15 by 15 meters on which you can land. And so while there is, of course, a little bit more complexity to this, if you break it down, it's really nothing else than a flat piece of land. And so the development of vertiports is both regulated by the government in terms of how they have to be placed, where they can be, what the noise level of noise congestion and so forth can be. And then on the other side, you have the technical capabilities that they need to have to host an aircraft for us. So how we think about this is that, one, we have a lot of helipads that we can essentially just take as they are and embed our systems into that. And then second is we can develop new vertiports, which we're actively doing with different developers across the country, development firms, large building firms, as well as corporates or IT parks and so forth, that develop then these vertiports given or sort of on the basis of the guidelines of the government, and then we build the system on top of that. Yeah, I think actually that the opposite is kind of the case. Like, yes, we will need significant infrastructure development, but if you look at the category of mobility, then we actually need barely any infrastructure development if you compare it to subways or railways or roads. The Bengaluru metro line, 1 kilometer of metro costs 200 crore to develop. That's a significant amount of money, and that's just 1 kilometer of railways essentially. So one vertiport or one helipad really to develop is somewhere between, let's say, 10 to 20 lakh. That's a different scale. And so we think that the technology here, the infrastructure here will take off a lot more, because historically what India is really good at is leapfrogging technologies that are infrastructure heavy. We went from grocery stores straight to Swiggy. We went from cash straight to UPI. And there are countless examples of that, where the actual physical infrastructure heavy solution, like credit cards, was skipped, or like grocery stores was skipped, and instead we went to the infrastructure lean model. And I think this is the equivalent in mobility for that, where we skip the infrastructure heavy roads and rails and go straight to the very infrastructure lean solution. I want to take that question from a historic approach. What we have seen with we don't think about that a lot, but cars were invented 130 years ago. That's really not a long time ago. But the way that they have shaped our cities is dramatic. Today, I mean, I just came from Indranagar to Kormangla for the shoot, and it's crazy, right? It's like 2 kilometers, and it takes me 40 minutes to get here. And that's because we have developed this infrastructure that is not capable of hosting or providing for the kind of demand that is there. So I think that the infrastructure of the future is really difficult to envision, but you just have to imagine that cars are not sort of a given. You know, cars are not there since forever, and roads are not there since forever. And I think the beauty of this infrastructure, if I see it in the long term, is that we will have small helipads everywhere, landing pads that get smaller and smaller and smaller over time. And that will free up the ground space so that we finally can have some space, some public spaces again, where we can go out and maybe grow some vegetables or go to play football outside, whatever it might be that you would actually want to use the streets for. So streets will go, and small landing pads will be everywhere. Yeah, I think one of the most important, if not the most important thing about our company is that we are assembling a team that is very, very capable of developing serious aircraft programs that are global standard in quality, which is significantly important because safety is above everything in aviation. And one key pillar in that is the part of the team that has developed these electric aircrafts in the West and, like I said, in the United States or in Europe prior to coming back to India to develop with Sarla. And I cannot overstate the importance of our team members that have that kind of experience, because how we built the company is that essentially every vertical that we have across every subsystem is led or at least advised by someone who has done a very similar product development in the West before. And that then ensures that we build the best quality products that there can be. There are plenty of tech bottlenecks that we're working through, but the good news is that they're all just engineering problems anymore. So we know that the technology is proven, and how we look at this is that now it's time for us to develop an aircraft system that works on a system level that is optimized specifically for India. And so the question or the technology bottlenecks, you know, they reach from subsystems such as landing gear all the way to motors, inverters, batteries, software, and so forth. All of these are challenging subsystems in and of themselves. But the really tricky part is to integrate them all and make them work together. It's like different organs in your body. Each one of them individually is difficult to develop, but then making them all work together in harmony, that's the tricky part. And that's the biggest tech bottleneck that we're having overall in the aviation industry, especially here in India, because that part hasn't been here before. We have developed certain components for certain aircraft, but we have never developed an aircraft that really brings all of the different components together, makes them all work in one system. I mean, this is a new space that is being developed where you have to develop the regulations kind of as the progress of engineering develops further. And really, there are two parts to this. One is the regulations for the airspace, for the actual traffic that we see. The other side is the certification and regulation for the aircraft itself. For you know, in our case, we call it Shunya, which is our first product. So these two things are kind of the regulatory bits. And on the airspace regulations, we see tremendous progress, you know, on a monthly basis. I mean, the Ministry of Civil Aviation around our Honorable Minister, Ramon Naidu, has been incredibly helpful and progressive in developing these policies so that the travel of these aircrafts can happen in India, and that we will see these systems emerge. Now, on the other hand, we have to certify an aircraft all the way from scratch in India, which again, a private company has never done before. So this is a long process that breaks down into all into a lot of different sub milestones and key results that we are seeing there. The initial ones are DOA and POA, so the design organization approval that let you where the government accepts you as a company to develop and design aircraft, and then it goes forward over time. So I think there is not so much of a known unknown as there is a known roadmap that we have to just comply to, and that takes time and effort. They actually don't really differ from that, so that's a good thing. We have worked with the EASA in Europe and the FAA in the United States prior to building Sarla, and the aviation industry in general in all democratic countries of this world have somewhat similar guidelines. So in our case, India and the EASA in Europe are working closely together. DGCA in India and the EASA in Europe work closely together to developing these policies. So because we have experience working with EASA in Europe, we kind of know where the Indian government stands and what this kind of safety standards are that we have to comply to, which is really helpful in our case. But yeah, the simple answer is that it doesn't really differ. Yeah, I think that first of all, it's important to mention that all of us have the same interest, regulators, VCs, startups, which is that these systems are safe. We all only win if these systems are safe. So what we have to develop is processes and test plans that make sure that we are 100% sure that these are safe systems once they go live. And I think everyone can work towards that. But really, it's between the regulators and the startups developing this technology where the safety compliance comes into the picture. And I think the rest of the story is really just creating awareness and making everyone excited about such technologies, because it's a lot of work. It's a lot of work putting these regulations together, making sure that we are, well capitalized as startups. As a startup, it's a lot of work to develop the technology, and we have to all collectively see the upside of this, understand that the traffic congestion as it is today is not something that is just given, something that has to be that way. It's a chosen problem, and we have the choice to find a solution to it. But that solution requires work from each one of these stakeholders. Yeah, I think on a foundational level, again, what we can look at is historically other modes of transportation. So it's interesting because today, we take the metro in most major cities around the globe, here in Bangalore as well, and we think that the metro is a very affordable mode of transportation, but it actually didn't start as an affordable mode of transportation. Trains used to be very expensive and a very premium way of moving from one place to another in the beginning. The same thing is true for cars. In the roaring 20s, the major car market was actually were cars only for the rich, very luxurious cars. And the same thing is true to an extent with this technology as well, where we don't want to build this for the rich, but we know that the initial pricing is going to be a little bit higher because that's just what it is when you have when your system isn't fully developed. But what we see over time is that because they're electric, because they don't need a lot of maintenance, the unit economics really get more attractive as the number of user grows. And that will also, what we will also see is a change in form factor of these aircraft. So initially, like I said, to offset all of the cost for the pilot, for the operations, for the landing fees, for the insurances, and so forth, what we chose to do is to split the total operational cost and the capex by 6 passengers, which makes it a lot more affordable than anything else and actually makes our aircraft the only one that has a fair shot at being priced at prices similar to ride-hailing apps today. But then over the long term, once we are fully autonomous, once maintenance is becoming lesser and more automated, once the supply chain for maintenance and spares and parts is going to develop more rapidly, Once regulations are more automated and air traffic control is more automated, what we will see is that they get smaller and smaller in size to the point where you will have two-seaters flying around, just how you know it today from auto rickshaws. And these then, because they're fully autonomous, will be very, very significantly lower in cost than any other road-bound transportation that you have today, because the utilization of these aircraft is actually a lot higher. If you take a car today from Kormangla to Bengaluru airport, then that cab is blocked for an hour, essentially, meaning that your car can only transport that one person or two people for that hour, and makes maybe 1,500 rupees in revenue. But in our case, because we travel so much faster, we can generate a lot more revenue in the same amount of time that a car generates very little revenue because it's stuck in traffic. Yeah, so the sequence of that order, or the execution plan here, really is simple. What we think is that initially, because our price point is going to be a little bit higher, what we want to connect is places where we know that people to whom time is really valuable will be traveling frequently. So that we have that we think is our initial market. So we know that there are 4 million people that travel between Bengaluru airport and every five-star hotel across the city per year. So this is our initial customer base. So what we do is we connect these places with each other and then just fly, one spot to another. And then we put IT parks into that equation, and then we take malls into that equation, and then other organized places from schools, hospitals, universities, whatever you can think about as an organized place, will be connected with each other. And then once that is up and running, that's when we will see, hundreds of these aircrafts being operational. So then we will collect the data that then will allow us to go point to point, essentially, and build like smaller, even on private houses, landing pads for smaller aircrafts that then will fly fully automated between point to point. So the idea is to go from bigger organized places into smaller and smaller and smaller grids of networks. Yeah, exactly those. So I think airport transfer is the initial use case that everyone is looking forward to. In places like Bengaluru, the airport is relatively far out the city. So everyone who has to catch a flight and has to cross the Hebal flyover knows what I'm talking about. You are basically stuck in traffic for half an hour on a distance that's anyway 1.5 hours. So it's a pretty bad situation. So connecting the city center and connecting Whitefield, electronic city with the airport is going to be our initial use cases, and that's what we're looking forward to. That said, that's just the commercial side of it. The other side of it is that we want to launch a totally free of cost air ambulance system, also at the same time, because we think it's tragic that people are currently losing their lives due to ambulances being stuck in traffic. So, but that we won't monetize. That we are very clear on. That's something that we don't want to make profitable. Yeah, a lot of these global companies have a lot more capital than we have, and they have been working on this for longer. The good news here is that we have been these companies. We have worked at these companies, so we know where they are, we know what the technology looks like, and we know how they kind of spend capital. I think that, again, the challenge here in India is that we can't raise these kind of amounts of money. We will probably not end up raising $2 billion for Sarla Aviation. However, we will be a lot more efficient in the way that we use money. And one of the most dramatic ways in which that comes through is that we are actively thinking from day zero how we can generate revenue even prior to the entry of air taxis as a service. So we have ideas and ways that we can find ways of generating revenue prior to our air taxi business. And that will give us really a head start, because we will be the one of the few electric air taxi companies globally that will start making revenue before the passengers fly with our air taxi. I would say vertical integration and supply chain, and that kind of trickles down into cost. IP is certainly one of them. We're very proud of the IP that we are developing, but the IP is also very specifically for our aircraft. So it's not really something that someone else might necessarily need so much, because like I said earlier, all of these aircraft systems are specifically developed for one aircraft only. You cannot just replicate that for take the motor out of our competitors' aircraft and then put it into ours. It's not going to work. So while there are technology achievements and advancements that we're proud of, such as our powertrain, there are other modes that we see are probably going to be bigger and more important, like supply chain development, building the ecosystem in India that will supply us with the necessary components, and then vertically integrating as many of the key components that as we can, and all of that combined will end up in a cost advantage that will be dramatic. We project that we can be 3 times more capital efficient, both in building the aircraft as well as operating the aircraft, than our Western competitors. I think India just has to keep going at it. I think that we all have to understand that this is going to be a lot of work, and it's a huge effort, and it doesn't happen overnight. We are somewhat used to quick success, because that's what the software industry has brought us. This is not like that. This is a long-term game that we're playing here. This will take tens of years to get to the point where other countries in aerospace are today, whether it's from a regulatory point of view, or from a funding point of view, or from a technology manufacturing point of view. All of these things take a lot of effort. They're difficult to develop because we're operating in the air. It's very critical that everything is safe. And I think the best thing we can do is just to be aware that this is a marathon and not a sprint. And so we have to develop one day at a time, and constantly keep hitting the safety standards and the quality standards that are difficult to achieve, but we're well capable of achieving them. I mean, I don't know. This is a huge question. I think that for the next generation of Indian deep tech startups, I hope that we can develop something like an Indian deep tech startup ecosystem, that we're part of that first wave of really significant manufacturing deep tech companies that are coming up in India right now. I think the typical things. I hope that more and more companies will get into that space, will look at that space, and really think about what the impact on humanity can be with technology that we're developing. And I think that's what we will give to the next generation in general. Outside of inspiring people to also build crazy stuff, I'm a lot more excited about the impact that we can have on a much broader scale than that. So if you if you can fly from one place to another, as simple as booking an Uber today, that's going to be a huge impact on all of our lives. That's going to change everything from the way that we live, the way that we educate ourselves, to the way that we work. Healthcare, everything will dramatically be different. And I think the impact of that, of the economic and societal change that our technology holds, that's really the impact that I want to see for the next generation. And I want every founder and every deep tech founder to think about how we can progress humanity by developing these incredible products that we get to develop here.